done by friction, okay, on a curved surface. Okay, so work done by friction on a curved surface. So how do we do this? So suppose we have a surface like this. Suppose we have a surface like this. Okay, so the friction coefficient is given mu, and object is sliding from here. Okay, so curved surface, and suppose object is moving slowly. Let object moving slowly. Let object moving slowly on the surface. On surface, okay, this is point A and this is point B. From A to B. Okay, so we will try to see what is the work done. Okay, so suppose the object is here. Object is here. So work done by friction we have to find. So mg is acting downward, normal is like this, and friction is acting backward. Okay, so suppose incline at this point is theta, which will be changing. The theta here is at this point, but the theta will be changing. So the work done by friction, how much we can write? Will it be equal to friction F into ds? The dWf I am writing. Why dWf? Because friction is changing. The direction of friction is changing because the surface is not straight. Surface is curved. So because of that, the value of friction will change, and therefore I am writing it like this. So, but in this case, we can say the friction and displacement are always opposite. So if they are opposite, we can write like this: F ds. We can always write like this. And the value of friction is how much? It is mu times normal into ds. Okay, so how much is the normal force? Is it mg cos theta? Mu mg cos theta into ds. Okay, so we can write like this. Now if you look at this surface, suppose this is theta, this angle is theta, and this is ds. Okay, this is ds. So if you write ds cos theta, for this part I am magnifying this part, and I am seeing magnified version of this part. So if this part is ds, then ds cos theta, will it be dx? Ds cos theta, will it be dx? So can we write minus mu mg into dx? Okay, and for getting the total work done by friction, we can write integration of this thing. So see, mu and mg is constant, and dx integration will lead to what? Total x. So x is what? X is the horizontal displacement. So total x, if you see, what is the total x? The x, how much is x? So x is this thing, the horizontal displacement. The x is horizontal displacement of object. Okay, so if the object is moved on an incline from point A to B, the work done by friction is given by minus mu mg x. The work done by friction is given by minus mu mg x. Okay, so this is the work done by friction. So this formula you can memorize. Means you can directly write mu mg into horizontal displacement as work done by friction.